So what you've probably done is taken a data set like this and you've split it into training, and then this is validation, and this is test, right?
Mm-hmm.
So another thing, so this is one way that you can do it. Another way that you can do it, which I'm pretty sure is called K. Actually, I should probably look this up before I say it, but K-fold cross validation. I hope that's it. If not, then somebody will need to forgive me. Is basically you break the data set up into, say, let's say like 10 of these, right? And then you essentially run this 10 times or some number of times, where the first time you run it, you might pick, this as your validation and this as your training set. The next time you run it, that's your validation and that's your training set. Next time you run it, that's your validation, that's your training set. And so basically you kind of run through all series of these, and then you take all of these and you average the results. You average your coefficients or something like that. So that's one way of doing it. If you found that if you found your training error is less than your validation, which is way less than your test, then you'd probably want to try this, or try, if these here were randomly selected, you might try to pick a different random selection for it and see if this ever changed. So that's something you might do there. If your training error is much less than your validation and is much less than your test error, then that means overfitting. And there's generally, I want to say, 3 things you can do. More data, fewer variables, and the idea of this more data or fewer variables kind of works like this. Let's imagine that you had 10 rows and 10 variables. Then you might actually get a solution that was essentially one coefficient per point. That's perfect. And that would be perfectly overfit. And if you ever tried any other sort of data on that, it wouldn't work. So this is kind of this idea here of you want your number of variables to be greater than, sorry, wrong way. You want your number of samples to be greater than number of data. Now, there's no rules on how much bigger it has to be, but the book said 10x. You really need to find something like whatever has the most amount of signal is what you want. But when you find that it's overfit like this, it's more data, fewer variables, or there are techniques to address overfitting, and it's called regularization. Which is, I don't know if there's, basically you have a term that, how do I describe it? I'm not certain I know it well enough. Well, there's something called regularization, I guess, which if you're looking like, B0 plus B1 x1 plus B2 x2, you have these coefficients. then you start adding in these lambda values per variable that you have, where these here are calculated coefficients, and these here are terms that you add in, and it's a learned parameter. And basically, the larger this term gets, then the smaller these terms get. That's the purpose of it. And so it's a mathematical technique to try to reduce overfitting or to reduce the dominance of one of these variables. Normally, in the things that you're running, this is just something that you can fit. This is something that you can set. There's a regularization parameter. So those are the three things. Generally, your algorithms are already trying to do this in some way. So these here normally become the things that you try to change. If you find that your data is overfitting, you either reduce the number of variables or you go and you get more data.
Yeah, when we ran the regression tree, it only used 3 variables.
You told it to, or that's what it decided?
That's what it decided to.
For the best prone.
Wow, okay.
Yeah, out of 45, it selected 3.
Yeah, okay. Yeah,
And
so
right.
that matches with this idea right here, that it found that the validation error was high when it had more variables. So to reduce the validation error, it tried fewer variables until it got the lowest error in validation. And then it determined that 3 was the right answer based on how much data you had.
Mm.
But you said you had 7,000 rows?
Mm-hmm.
Yeah, 7221.
Did you have what did your collinear matrix look like? Your coefficient matrix or covariance matrix? Sorry.
I couldn't get the multiple linear regression to run.
No, I mean the covariance, like where you look at how the x's and y's go across each other. Did you look at that at all?
No.
That is in Excel.
Are you talking about the native solver, right?
Yeah.
No, I didn't do that.
I wonder if you'd see anything there. That is oh, come on, move over.
I thought that was one thing that the multilinear model would pull up by ASDM.
Yeah, it probably does.
Yeah, so I didn't think to go the solver route. I just tried ASDM, and for multilinear, it just wouldn't run. It would hang up. It's probably like my 3rd time trying to run it.
It might be hanging up because some of the data is very highly linearly dependent on each other. A lot of these things work off of the linear algebra under the hood is it's trying to divide by things, and when you have a lot of columns that contain the same information, those things tend to lead to zeros in the denominator, and things tend to blow up, which could be the reason. I mean, the technical term is saying that the variables are not linearly independent, that the variables are not linearly independent of each other, and you're trying to invert a matrix. There's no inverse to a matrix where the rank doesn't equal the variables. The technical way of saying that when you try to invert something that looks an awful lot like each other, you end up dividing by 0.
That's very possible because I think we decided to leave in the review column, and then there's like different kinds of review, right?
Yeah.
So that that was one of the idea we thought maybe we'll throw that out, but we haven't.
But-
One of the idea we had was just pick and choose like different variables, and maybe that'll help our
Well,
model
look at
to run.
look at your correlation matrix. So let me pull up. You guys are seeing my screen, right?
Yeah.
Home.
Yeah.
Okay. So here on mine, you can just do under data analysis. It's the correlation is what I wanted. Input range.
Oh, you have a lot of data too.
Yeah. So. Get rid of actually. Oh, because I have. Oh, labels in first row is probably why I was complaining. Columns, rows, labels in first row. Aha, here. And then what is it he did? He did the home, conditional formatting, color scales, and picked one of these heat ones. And so here, so you can see here that, so credit score correlates highly with credit score. And then when you look at geography, France, and against geography, Germany. So here, France and Germany have approaching high correlation of negative 0.5, which is almost highly inversely correlated. Gender female is highly correlated with gender male. It's exactly inversely correlated, which is not surprising for this particular data sample, because if you weren't labeled one, you were automatically labeled the other. So they only had binary classification. So essentially, if you do this correlation on your data set and you find that a lot of these are have ones or 0.95s or something like that with each other, that might mean that there's a lot of overlap between columns. And so you might want to delete those columns because those columns are just combinations of other columns, and that leads to numerical problems.
Sounds good. We'll try that.
Yeah.
Thanks, Mark.
No problem. Another thing that you can do, like, is you know how you probably did your data analysis, and maybe you found some variables that were maybe you plotted some numerical variables against the output continuous variable, and if you saw that there were strong linear relationships in those, you could try running a regression with just that small subset of variables and seeing if you get better looking data that's not overfit. It might be not as accurate. Your ROC might be, the area under the curve might be a lot worse, but you may see the overfitting go away. And then if you see that, then from there you kind of start adding variables back in to see if you get a better prediction without seeing the overfitting come back in. And this is where data analytics kind of becomes a black art, because you just kind of have to try things. It's a lot like cooking. You're never sure. You have an idea of what's going to taste good together, but you never know until you actually throw it all together to find out,
And I'm curious after seeing this, I'm thinking what we could do is take our 5 highest variables, since we only have 50 rows of data, instead of running it with the 15 or 20 that we have in terms of variables, we run it with 5, the highest, and see what kind of lift chart we actually get based on the same 50 lines of data. That we have.
Yeah, and I was thinking you might even, because if I remember right, you had like a bunch of different metropolitan areas.
Yeah,
And so you did individual analysis for each metropolitan area,
we haven't done that yet. That was our next step.
throwing them all together, or
We
doing them
ran it
separately?
all together. We ran it all together. Our next step would be to break it out.
Oh, that's interesting. Breaking it out, I would suspect might make it worse, but it may not. Again, it's that whole general concept of signal to noise ratio. And if you segregate them by metropolitan area, you might get rid of a lot of noise,
Hmm.
you know, and because it might be that a given region really has distinct characteristics. When you overlay that on all of the other regions, maybe those characteristics are hidden.
Yeah, that's a good point.
You know, you really, and there's like, you'll find this everywhere that you read. There are no rules on this. There are only rules of thumb of things you can try.
One thing I had a question about was, you know how for separate or partitioning data, we use the 50-30-20 for training, validation, and test.
Yeah.
Would it be understandable to change up that number somehow, or?
Absolutely. You could try 80-10-10.
Oh, okay.
You could try 90-5-5. You know, 90, 5, 5. It really, like, imagine you had a data set with 100 million numbers. 90%, 5%, and 5% would be, you know, 90 million numbers with 5 million training records and 5 million validation records. Like 5 million's a lot. So you could try it and see if the overfitting problem goes away. But I would guess if you find that that by changing the ratios causes the overfitting to go away, then you would get the same, the same result if you did that cross-fold validation thing. You know, just run it 10 times, alternating which percentage is your validation, you know, which chunk you use for validation and which chunk you use for testing and training. And by averaging all those, you should kind of get the same result.
There's no way to do that cross-fold in ASDM, is there?
I really hope I'm calling that thing right.
I didn't see it under the typical 2 drop downs we get. So I don't know if you explained that before or Andy covered it, but like when you start drawing it out, I'm like, that looks familiar.
Yeah, he definitely did talk about it.
Yeah, but I don't remember
the
doing
examples
it.
or homework assignments had that in there.
Oh, okay. Because I was like, I don't remember seeing this in ASDM though, so.
Let's go see. Let's find out what happens. Variable. Data range, really? It's not automatic.
This class does make me feel like I should have tried an MS in analytics before doing this.
This class would, yeah, I think you get a lot more out of it if you had that. I think this is for first time exposure, you know, given that many of us haven't done math in 20 years, was a lot to ask for, both application understanding and detailed understanding. You know, there we go. Okay. So let's see. In partition data. No, it doesn't look like they have it. I think that that might, please just let me exit this. That might be what bagging is.
Mm.
Um, no, they talked about it here. Ensemble methods, blah 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 blah. Bagging. Yeah, they bagging is probably impossible to read for anybody. View. There we go. So, oh, come on. So bagging approach, repeated sampling, they construct multiple training sets. So, unique observations. Bagging may not be exactly the same thing. It's kind of a general idea, though. You select the data and then you put it back. Select the data, put it back, and you keep pulling that from all of your samples. Yeah, I don't know. There's all sorts of methods to try to address the problem of overfitting. It's a very common problem in data science.
Mark, I just quickly ran the correlation
Yeah.
and I did the range, and it's telling me that my data has non-numeric data in it.
Yeah, it probably just means pick. Did you select the button that said first row has headers?
Yeah.
You share your screen?
Yeah.
Victoria, you might have to delete the columns that aren't actually using.
Okay, hang on a second, let me-
Was I showing my screen when I went to big? I wasn't showing my screen when I was reading the book, I think.
Nope.
Nope.
No. This is what I was referring to.
Your
Ensemble
codes?
methods and bagging here.
That's a bunch of code.
I
bunch of
see
code?
colors.
Come on, Mark, you don't expect us to read that.
Oh,
Mark, I see
wrong-
colors.
Wrong screen. Sorry.
That looked
Boy,
like
it's a good
alien
thing,
language.
good thing I didn't select the screen to the right. That would have been really bad. No. Here we go. Ensemble methods here. Bagging. It's similar. Yeah, he did talk about that method of averaging and trying a bunch of stuff. I do remember him doing that. But you want to share your screen, Victoria? Maybe I can.
Yeah, sure.
spot
Okay.
the problem.
Are you seeing this?
I am, yes.
So Amy, I'm actually able to do data analysis under data, just not the data mining.
Okay, so input range, correlation, C24, B. Yeah, so it doesn't like E or C. It doesn't like
E
row
or
E or row C
Okay.
or row M. Doesn't like any of those rows with words in it.
Words in it. So how do I just get rid of it, or?
You might have to copy the data set and then just delete the ones that we aren't actually using. Because with ASDM, we can select which one we want, but I think with the native Excel,
Okay.
it's a continuous.
Okay.
Yeah,
Yeah.
what Amy
So
said.
just come up with another one and then that only has the numeric.
Yeah, like everything we wanted.
The
Like,
numeric
everything is,
and the encoded, the one hot variables.
Yeah.
So, your host response time.
yeah. No, we drop all of that. I think our real data set, I think, start from column N, but there is I think even in between there are some columns that we decided to drop.
Yeah. Yeah, like there was a bunch of data in ours that we dropped that was unique, like we had customer IDs, which there's no reason to have that.
Right.
Yeah, we had to drop a bunch of data too because it was just blanding everything out. We went through and dropped quite a few rows because the picture just looked a lot sharper, dropping out these kind of muddling pieces of data.
Yeah.
When you say dropping, so you're actually eliminating it from the data, the data sheet.
Yeah, it
Okay.
was just, I mean, we would run a regression, and the decile chart would basically be like 10 columns of identical values.
Right.
So they're really mudding up the data. And so once we pulled them out, then we started noticing a good separation of our charts.
Okay.
And that's something that you guys can do too. Is I don't know how many columns you guys have, but just go through and start dropping off columns and see if it changes
Yeah.
the look of your data.
Yeah. My guess is you have a lot of co-linearity.
Yeah.
Okay.
Or like a column where almost every variable is the same thing, right?
Right.
So for instance, like host has profile pic.
Like this one is probably not that many.
Yeah.
Host has profile picture. That's probably not relevant anyway.
Yeah, exactly. So what Ben said is exactly right. Like,
Right.
Okay. And you might even see that like when you do your when you plot do your whisker plots versus a continuous variable, for instance.
Mhm.
If you see that the two box plots are right on top of each other like that, you can just
Right.
get rid of them.
Okay. All right. Sounds good. Thank you.
Welcome. I will be right back. I have a splinter. I'm gonna get somebody to remove before they all go to sleep.
Good luck.
Oh yeah. Okay.
That is the worst. Have you guys met with Andy much for the project?
We met up with him on the proposal only. We're gonna try to meet up with him again sometime this week.
Oh, okay.
Yeah, we've sent him a bunch of emails, but we haven't met up with him yet. It's not a bad idea.
Yeah, we met once with him, I think shortly after the proposal, and then haven't reached out yet. But we've since we run a couple of items already, probably would be a good idea to check in with him soon.
Yeah.
I don't know if you guys know, but like there's actually I pointed out to him that it wasn't on his the data project description, but apparently one of the expectation is to have a one-page summary and I asked like, well, it's kind of like a handout, and he said yeah. So like if we were in class, you hand out the paper
Much
to
better.
people. So that's in addition to the presentation
Oh,
and the deck.
Oh, there's supposed to be a handout? That's good to know.
Yeah,
What?
it's like a one-page summary. Oh, I was talking about like when we met with Andy, he mentioned that one of the deliverable is actually a one-page summary, like a one-pager for people to take with them.
Oh.
And I was like, that's not really clear. Like it's not really in the, so there's like one line in like the very first paragraph of the project that says that. And I thought he was gonna address it in class, but I don't think he did yet.
It's good to know.
That is very good to know. Thank you.
Yeah, because I wouldn't have done that.
Yeah, same. Just FYI. Are you guys comfortable with the regression tree and ensemble methods? I still need to go back to rewatch the lecture on ensemble.
Yeah, I probably need to rewatch it as well.
I think
Yeah,
that's on the
so regression tree is basically, well, I think you talked about it. You take a data set and like you draw a line, you divide it in two, and then you come up with yeah, you come up
boxes.
with a label for it. What was that?
Boxes.
Yeah, exactly. And then you divide that and you divide that. It's literally a decision tree. I mean, and you can have as many nodes as data points, which is what a decision tree would naturally do. And then, so you could have a decision based off of every data point. And so you'd have 100% fit on the training set. But normally with a decision tree, you select fewer branches than data points. And ensemble methods is basically just a collection of methods tried simultaneously to classify data. And then there's bagging and boosting, which are two different types. Bagging is where you, I think is more similar to the example that I was giving. Boosting is where you run a classification, and then for all the samples that you misclassified, you throw back into the pool, and then you reclassify. So basically, the idea is that the ones that you miss, you throw back in, and you say try again, and you keep doing that over and over, being that you force the regression model to work harder at the things that it doesn't know how to classify, and you just let the easy ones come out. It's essentially the concept behind boosting. So boosting is when you try to retrain on the models that it makes a mistake on over and over again. And a lot of times you get better results from that.
Would it not end up in overfitting case though? Or?
It could. But the idea behind it is that you have a lot of data samples and some of them are easy to classify. And so you're saying, I want you to really focus and spend your time on the things that you have trouble classifying, which is, seems to work better than, seems to work better than just a regular method.
I think these couple topics are going to be on the next quiz, right? That he's going to release probably sometime this week.
Yeah.
And then the last one is kind of open assignment, or not open, but he's going to give us ahead of time on the LP.
Mark, is there one method that you feel that maybe we would benefit from your further explanation?
Well, yes, if I had, I still am not I still don't have much to say on them
Okay.
in a way that would. So I guess if you wanted to ask me questions, I might have good answers, but on my own, I don't have anything that I could lecture on
Okay.
and give additional information. Certainly not as much as I had in previous sections. So I just haven't spent a lot of time with classification trees or ensemble methods. I really, in the class that I took where I did those, was almost exactly like what we did with Andy. It's like this was,
Okay.
you know, the 10th week of the class, and they said, by the way, here's all these other methods. Here's how you do it in Solver. Good luck. Sometimes these work better,
Mhm.
which is pretty much the same thing we got here. And it's basically kind of the same. The general principle I think that Andy has been getting towards is that when you know how to analyze these models, what the model is doing underneath is well, I guess certainly what he quizzes us on, but you don't need to know it in order to use the analysis. So when it comes to like classification trees and ensemble methods, it's okay just to say like I tried it and I got a better prediction. Here's how I can show that because the F1 score was better, the area under the curve was better, or you know, I really wanted as few false positives as possible. And this method gave us the fewest false positives, you know. And so for a lot of these methods, especially the last three, it falls into those camps that understanding what goes on under the hood is less important because once you've seen one, you've kind of seen them all.
Mhm.
So the classification tree really is just try to build up a classification method through a series of coin flips. Where maybe coin flip is the wrong word, but you know, it's A or B, and you just keep doing that for every single data point until you have the accuracy you want from the classification. And then we showed that way of optimizing it. So yeah, all those things I kind of have to. I still need to go in and learn them well enough to be able to explain them. I'm not there yet. But if you have questions, maybe I do. Maybe I know more than I think I do.
Well, analytics solver just crashed my Excel. So
Yeah. And you're running the data set that was barely better than the line, the average line.
it's like I think the way Victoria put it, it looks like an archer's bow. So it's very it's above the line for sure, but it's like barely. I mean, yeah, it's like a tiny gap.
Yeah.
And when I look at the decile chart, it's not really. It doesn't really.
So if
help.
solver is crashing, that tells me it's one of two things. It's either your system is running out of memory,
Yeah.
or there's a lot of divisions by zero.
It's possibly both. My computer's just been super slow today.
Yeah, and it might be.
And so is mine. So that may explain why. And I think a couple members were having trouble too.
So you could try running it on a smaller data set. So if you have 7,000 rows, try running it on 1,000 rows and see if it works better.
But keep the 7,000 on the data sheet and just run less.
Yeah.
Maybe what we need to do is go back and delete the columns first.
Yeah, in either case, yeah, 40 columns is a lot.
Sure and happy that we didn't use the 150,000 data set.
Well, so that's the thing though, is that for the number of columns you have, like, but you have 7,000 rows. Yeah.
So we actually did chop down, like raw data wise, we did chop down our variables to like about 20 or so. It's one of our columns is in geographic area essentially.
Yeah.
And then they categorize, and it's already cleaned up by the time we got the data, because this is neighborhood cleanse. And they have 16 variables. We thought about kind of categorizing them into 4 or 5 based on, you know, our knowledge of the area.
Yeah.
But then ultimately we just decided to go with the 16 values, because I was like, well, that's a lot of bias that's built in from our personal experience.
Yeah.
So yeah, like that itself just adds like 16 or 15 extra columns. And then we
Yeah.
have two other categorical variable. So
Yeah.
just went
But
to
some
45.
methods handle linear independence much better than, or non-linear independence much better than other methods. So I think like the classification tree is probably pretty good at that.
Yeah, that one I was able to run. I think KN, someone else was able to run also. I didn't try Ensemble, so I didn't know like how that would turn out. Just
Yeah, I ran the KNN, and that's what that huge range of number.
oh no.
Yeah.
But I think our we're comparing the RMSE across the different methods, and I think on testing they're all in like the 400 range
And what is it you're predicting?
price.
Okay.
So our topic is the Airbnb, right? And then we have a bunch of inputs, and then the output is we're trying to predict this price.
Yeah. Okay.
Yeah. And it was really interesting because like we have, you know, 45 and there's granted 16 of them are based on neighborhoods. But when I did the best prune tree, it gave me bed, bath, and your cleaning fee that you're charging.
Yeah.
It's like none of the other things matter. It's just these 3 things.
Number of beds, number of baths, and the cleaning fee.
Yeah.
Fee, yeah. Not the deposit. The deposit didn't seem to matter, but the cleaning fee.
Interesting. I mean, that's like probably the only fixed cost, right? On top of,
Yeah.
I mean, the rooms and bath would be the total part of the total cost too. So like you guys had location and everything, and none of that mattered.
None when
No.
they did the best prune, it didn't even come up. The minimum error
No.
is the same exact table or same exact tree as best prune. The full tree, I think, went to 99 nodes, which I think he said is the max that we get to run with the basic version.
Oh, okay.
So
Yeah.
I'm pretty sure it's not the true full tree.
Oh, I see.
I did my classification tree on Python, and when I was doing it the first time, I didn't know actually that I needed to prune it down, and so it ran and it had like 100,000 nodes.
Oh my god!
And it was 100% fit on the training data set, and I was like, well, I know that's wrong, but I did it, and then I did it using the method that he talked about of optimizing the effectively what Solver called the best, what was it, the best fit model, best pruned model. So I implemented that equivalent model, and yeah, came up with significantly fewer nodes. I think there were still like 40 or so.
That's not bad.
No, it was about right. Yeah, like the training, there was almost no difference between the 3 data sets.
And how many variables do you have again?
We have 13.
Oh, okay.
We have 7. 5 of those are categorical.
Really?
Yeah. Well, I mean, of the 13,
Oh, okay, okay.
of the 13 variables, one is the 2 are male and female, and 3 are location. So 5 of the 13 come from two categorical variables. So the original data set, I guess, had 13, 5, that's 8, 9.
I'm surprised you guys didn't do binary on just the gender, like as in just pick one and drop the other.
Oh, we did, but
Oh, okay.
for some of the methods, you don't need to do that.
Yeah, like
So,
KN
so 13 is the largest number. Most of the methods, like logistic regression, we only used 11 of those because like male, has both male and female. So gender, you only need one column. We only needed 2 location columns for the 3 location columns. But almost all of the other methods that we did, KNN, decision tree, neural network, none of those needed to have that last, those columns removed. It's not necessary to prune out the additional columns, the duplicate columns. They work just fine with them. Did I lose everyone?
No, so Ben, I think Wednesday we should meet and talk about
Yeah.
the 4th quiz.
Yeah, I agree. I mean, whenever that quiz is due, I mean, if those quizzes are due on
Do we know
the Tuesday after,
It's
Yeah.
Tuesday after, so open this Tuesday and next Tuesday.
Right.
What did he say it's going to be on?
It should be on decision tree and
Classification.
classification. Yeah.
CART?
And cart. Yeah, and cart.
Wait, no ensemble?
Oh man.
I thought it was card and ensemble,
Yeah.
right?
Yeah. So it's ensemble, classification, decision tree, random forest, and cart.
And he's going to give us a decision tree, like the little boxes we have to make. All right, I'll see what I can figure out. Those are things that like I said, I haven't really looked at. So I don't know what I could add on top of what he added.
Are we doing like the problem set 4, 5, 4?
I suppose.
Should be 4.
It should be. Oh, I don't know. I thought the 4 would be. It's for quiz 5. Or something.
Quiz 5 is
I
going to
really-
be the optimization.
LP. Yeah.
LP.
Yeah, that's what I thought. But the deck is session 4 for that.
yeah,
Oh yeah. Sorry, you're right. It's the session 3 set problem set.
Oh, I see.
So it's problem set 3? I get really confused because we're
Problem
not
set
following the agenda. We're not following.
Yeah, I think it's problem set 3. Well, actually, yeah, chapter 9, cart and ensembles. It's number 11, 15, 17, and 23.
So it's a second set of problem set 3 because the first set is KNN, which we've already
Yeah.
gone through.
Mm-hmm.
I just love the fact that this class drives me so miserable, and we'll still have a quiz a week after the last class we have.
Oh yeah, that drives me crazy too.
I mean, I'm like, I want to be done on the 12th and never have to open this book again.
It's a final. It's a final exam.
Yeah.
It's like-
What we could do is, I mean, we had the class on Saturday. We can meet on Sunday like we always do. Everyone take the test on, Monday or Tuesday, and then we're done. We don't need to wait 2 weeks or a week to do it.
Yeah, I think that is exactly what we should do.
But Ben, if it's any solace, I broke my retainer recently. I think I've been grinding my teeth at night.
Oh, man.
So I need to pay up the money to get a new set.
That is rough.
It's not 903 though. It's 901 that's giving me a major anxiety.
Oh,
Really?
901?
Oh, it's
Really?
901.
901's
Yeah.
so much fun.
So after I spoke in class last week, I went and cried. It was
Why, what
so
happened?
bad.
What
Wait,
did you
what-
say in class? I don't remember what you said, Amy.
I just like tripped over words and I was just like, oh God, like in my mind, it was like a downward spiral. And I was like, oh man, I made a fool out of myself in front of Western Digital. And then
Dude,
yeah,
no one
after
noticed,
that
man.
was-
I didn't notice
even
at all.
No one
notice.
noticed.
that was so bad.
Don't be so hard on yourself, man.
Yeah,
Yeah.
I didn't even notice, Amy.
I was
I
like,
feel-
oh God.
I feel like everyone was too busy paying attention to their own notes that they were
Yes.
preparing to give to like even
Exactly.
hear what you were saying.
Uh-huh.
Yeah. So 901, I think we have one more session for that one, right?
I thought we're done.
No, we have one more.
Oh.
The week
Not this
present,
week, right?
Not this week.
Wait, what's
What?
this week?
This
So
week we have a
this week-
short class or something. We only have like one session on the Saturday class.
Oh, that's not showing up on my schedule. How
Oh, we
interesting.
do?
Oh,
Yeah, if you look at the calendar on the let me pull it up.
I'm looking at Camino here and I'm not seeing anything.
Let's see. This week is December. Oh, we don't have Friday class?
we don't?
Was it Friday? I thought it was Saturday afternoon. But let
Yeah,
me-
I don't think we have Saturday afternoon class.
Yeah, because there's no
Hang on a
strategy.
second. Oh, they wrote it wrong. On the calendar, it says Saturday, but then it says 5 to 9. Okay.
Yeah, so we got Friday 5 to
Friday.
9, and then we've got Saturday 8 to 12:15, and then the afternoon is free. But I'm going to talk to my strategy team to see if, since we have that time blocked out, we should just block out that 4 hours to work on our project.
Oh, that's a
I
good
was
idea.
supposed
It's a good idea, Mark. We probably should do that too. I think we're pretty
Well,
behind
I
on
was
that.
supposed to play a gig on Saturday. We were going to play a block party, which I think has been canceled now.
Yeah, I think everything's been canceled. We actually just got hit by the 2 weeks. What's it? 2 weeks quarantine if you're coming back from like 150-mile travel. So
Oh,
we're actually
yeah.
dealing with that at work now.
Oh wow.
They're like a bunch of people who all of a sudden are like, yeah, you can't come back into the office now.
Well, if I'm not playing a gig, we can do it. But if I'm playing, then I'm playing. I just
Sounds
want to
good.
get out there and play for people. It's been, oh God, it's been, last time we played was in March.
Oh man.
Well, for a crowd. Last time we played for a crowd was in March.
Yeah, so okay, I hate the way they scheduled it this quarter. Sorry, I know there was like 3 back-to-back weeks, and then I don't get why they didn't just give us the Saturday session this week and then end the last session early. You know, like things like that doesn't make sense.
I think it's for people like me because of the fact that I was out of town. I've been out of town all week. And if they had done like a Saturday session this week, I wouldn't have been
Well,
able
or
to
the-
join.
Professors might have been out of town, right?
Yeah.
Oh yeah.
Necessarily the students. I'm looking through slide 3 and I'm trying to guess. Like, I'm basically going through all of the red questions, trying to figure out which one he's going to ask.
But Ben, I guess the only thing is he's asked a basic math question on every single test
Yeah,
that he
so
hasn't gone over.
Impurity on page 75, like the 1 minus sum of p squared, pi squared. That has to be one that he's going to ask.
You know, actually, I was rewatching the lecture for that one. He actually went over it a couple times, so I wouldn't be surprised. Actually, when I was rewatching, I was like, I wouldn't be surprised if it's on the quiz.
Which
Yeah.
one is that?
Which one is this?
It's the Gini index, the impurity.
Yeah.
I remember when he was going over in class, I actually wrote it down too. I was like, oh, there's a formula. Better pay attention.
Yeah.
And it's in red. Like, there's a formula and it's got red text. Like,
Ben, that might be the pattern that I'm recognizing.
Yeah.
Gini index. I didn't even see that one. What session is this? Session 4?
Session 4, 70. It's on page 19 of the PDF, and it's slide number 75.
I think
Are you guys looking at the same thing I am? Because for me, mine says motivation under slide 75.
Huh?
Are you looking on session 3 slide deck?
No,
Session-
session 4.
It's session 3.
Session 3. Yeah.
Yeah, I just shared my screen. This here.
Oh yeah, that's gonna be on the test.
Yeah. I mean, he's got it here. He's got it here. He's got
Yeah.
red letters here. Like,
Yeah, that makes sense. And that's an easy one too. That's just basic maths.
do that. What did I do?
Would you just, so what you do is you'd get the PI. Would you add them and square them, or would you square each one and then add them?
You square each one and you subtract them all.
Well, no. So you do the sum of, though. You'd square each one, add them all together to get the sum of, and then subtract them from one.
Yes.
Well,
You
yeah.
sum all these
Well,
together.
because in class he basically did the 1 minus x squared, 1 minus y squared, whatever, like, or x1 squared, x2 squared.
Hmm.
If you watch the rewatch the lecture for that piece, he kind of calculates it. He writes it. He writes everything.
Yeah, I'm glad you guys brought this up. Like, I don't even remember this. Like, in my head, the whole thing that I was looking at is just I was trying to pay attention to the breakdown, the actual treeing of it that he was showing us to do. I think that's the thing that's happening to me. I'm kind of, my eyes are glazing over when he's doing all of this stuff, waiting for him to actually start punching stuff into Excel.
Yeah.
Because at the end of the day, that's what I'm going to use. I'm going to use Excel. I'm not going to use the theory of calculating this stuff. Yeah, right here.
Yeah, the Gini index on the first one was 0. Because it's 0 times 1.
Yeah, so P1 is 1 minus P0, so they're all equal to 1. And then the I would be 0, right? For the first one.
Yeah, this one, first one is, no, I is 1.
I is-
No, 1 minus 0.
Yeah. No, it'd be 1 minus
Minus 1.
1 minus 1.
1 minus 1, so
minus
the answer
1.
would be 0.
0, yeah.
I think when he drew it out, wasn't it like a parabola?
Yeah.
Yeah.
And so the second point would be 0.8 in a square.
Yeah, the square of 0.8. Negative, yeah, square of negative 0.8.
So that would give us 0.36.
So it's 0.01 plus 0.081, so 0.082, and the square of that.
Wait, what are you looking at?
I'm just trying to calculate it in my head.
Because wouldn't it be, so for the PI, it would be 0.1 minus 0.9 squared.
Yeah, so 0.9 squared is 0.81. 1 minus 0.81 is 0.19. Right?
Oh, I see what you're doing. You're squaring them first and then subtracting them. I was subtracting them and then squaring them.
Wait, what is it?
So you square PI first. Right, so PI is 0.9. So for the second one, we're trying to calculate the I. So it's 0.9.
No, that's P1 though, not PI. Isn't PI the difference between P0 and P1?
No.
No, the I is just the index, so it's 1, 2, whatever.
Like this one here.
Yeah.
That index, that index, that index.
Yes, that's how I was calculating it.
Yeah. So the second row there, the 0.1, 0.9, that's I got 0.18 as the answer.
I got 0.19.
Rounding error.
Right. Okay.
Wait, so you guys are just doing it for you guys are just doing it for P1 then, not for P0?
Yeah, because PI is just the index. So if you look at the red, it says P1 equals to 1 minus P0. So you can kind of see how he calculated the two columns, right, for P0 and P1. And now you calculate I for each one, and you just plug that I into the PI, which is the index number, and we put in P1 for each and calculate it down.
Okay.
So the second one is actually 1 minus 0.81.
Yeah.
And
That's
the
how I
third
calculate
one, and the third one is 1 minus 0.49.
Yeah, 0.7 squared.
Uh-huh. So you just
Five,
use
one.
the P1 as the mark for I.
I think that's how he calculated it.
Got 0.42 for the second one. You guys also need to subtract the P0 squared as well.
Okay, where do you subtract the P0 square?
It's the sum of pi squared. So it's 0.5 squared plus 0.5 squared. So here it's 0 squared plus 1.
Oh, yeah.
1 minus 1. So this is 0.01 plus 0.081, which is 0.082. So 1 minus 0.082
It's 0.18. Yeah.
Yep.
0.18, yeah.
That's why
Okay.
it's slightly okay. That good. That's where I was missing.
Yeah, so then this is 1 minus 0.05 squared, or 0.5 squared, which is 0.25, plus 0.25, which is, so it's 0.5. So it should be 1 minus 0.5, which is 0.5, right?
Yep.
Okay.
How come on mine it says 1 minus, for the second point, it says 1 minus 0.1 square and then minus 0.9 square. Is that right?
Well, yeah, because 1 minus the sum of two numbers is 1 minus, so 1 minus the sum of two numbers squared is the same as 1 minus the first number squared minus the second number squared.
Okay. All right. Gotcha. Thank you.
Yeah. Just pretend that's in parentheses.
There you go, Ben. That's your first 6 questions on the next quiz.
Yeah, I
Yeah,
know,
and
right?
probably, well, to be honest, like what he would do is he's going to do P0, P1, and P2.
Yeah.
And he's going to ask you to calculate the Gini index for all those. So you have to take this value squared plus that value squared plus P2 squared, add those all up together and subtract it from 1.
You know what he's also going to do is, you see it right there. He's given your P1 is 1 minus P0. So he's going to give you a bunch of P1s
Oh,
and
yeah.
say, hey, calculate the P0s, then calculate the index, because that's what he did on one of those previous questions.
No, usually he skips one. He usually doesn't ask you the P0. He goes straight to the index, expecting you to calculate P0 to get to the index. I think that's how you
exactly. But the steps are, you're going to need to calculate your P0,
Yeah.
and then you'll have to calculate the index.
Yeah, but he'll probably do it with 3 classes where there's a P0, there's 3 classes instead of just 2. You have to calculate the Gini index.
Good point.
And then the next question. I think the next question has to be along here. Like these things.
Like asking for verbal interpretation on each one of these?
Yeah.
That's not bad at all.
What would the verbal interpretation be? I think that's another thing that annoys me on his, he doesn't actually write the answer on his notes.
I don't know. Have to.
Yeah, just really zoom in. So if your income, I just went over this with my team today. But basically you're at the first level, right? If your income is 59.7, I think it's less than, and then you go to the left leg, and then you go down that route. But if it's more, I think it's greater than or equal to, when you're in ASDM and you hover over it, it will tell you the actual, signs. But one is usually, the left side I think is usually less than, and then the other one is equal to or greater than. So if your income is less than 59.7, then you want to look at your lot size.
Yeah.
And then if your lot size is less than 21.4, then you go to the left one, which is non-owner.
Non-owner.
Yeah.
So here, it's on this one right here, if you look on 6. If income is less than 59.7 and lot size is less than 21.4, then, so less than 59.7. So historically, I would say by tradition, in these types of trees, the left node is less than, the center is equal, and the right node is greater than. So to the left means less than income, less than this 59.7. To the right means greater than 59.7. So, and then here, he has lot size greater than 19.8. So 59.7 and lot size greater than equal to 19.8, then you're an owner. So I can imagine him giving us a question like, which of these statements is not true based on the chart? And he lists like 5 of these, and here on this first one, he says then non-owner. Like on this one here, say non-owner instead of owner, and you go through this and you say 59, okay, greater than equal to 19.8. Okay, it's supposed to be owner, so that one is wrong.
And I think from this, we can see that there are 24 data sets, right? Because the 2 legs on the very top level.
Yeah, so this means that there were 8 items that were less than 59.7 and 16 items that were greater than or equal to 59.7. Right?
Yeah.
Mhm.
Yeah. And so then here, this is good, because then we know we have 8 items going into lot size. And so 7 of them got classified as non-owners. 8 of them got classified as owners, which is helpful because there's 8 going into it. So these 2 legs should equal to 8. Same thing here.
Mhm.
16 going into lot size. And this gets split into 9 and 7. So there's 9 to the left, 7 to the right. 6 plus 3 equals 9. 1 plus 5 equals 6. So since he never asks us homework questions, like those are the ones. Otherwise, what else is here? Case.
Why no perfection on the training set?
What was that?
Why no perfection on the training set?
Question on the training set?
I thought I was in the same area as you were. Sorry.
Oh, why the perfection on the training set? Here we are.
Yeah.
Why the perfection on the training set? Accuracy. Oh, it's a fully grown tree. So, damn it. I hate it when I do that. I don't know what the magic combination is, but when I get it to where it's highlighted that dark blue, I can never get rid of that dark blue highlight.
No.
So let's go back. 117. Okay, so on a fully grown tree, you basically have a decision point. You have a branch or a node for every single point. So every single point on a fully grown tree is categorized somewhere, categorized accurately. So nothing is collapsed, I guess. So when it says, do you expect a fully grown tree to show better or worse accuracy on the test set than on the validation set?
Better accuracy.
No, that was a point. He made this in lecture. This is the one where I typed, like that'll be a question on the quiz in the class chat. That was one where he said, like, there's no correlation between test and validation set on this one.
Oh.
Like, go back in, God, when was it? What time did I type it on Slack? Why I did it, class chat. Where analytics? It was, I said, that'll be a question. What day was class?
21st.
Oh, there we go.
There,
So you-
8:02 p.m. That will be a quiz number 4 question for sure. 8:02 p.m. Go find what he was talking about at 8:02 p.m.
You wrote it, Mark.
Sure.
You wrote it.
What's that?
You wrote it. Go back down. Go into the chat. It was the one right below it. Do you
Yeah.
expect? Yeah.
Oh, yeah. So better or worse accuracy. There's no relationship between the two. Totally independent. Cannot make that assessment. Yeah. Guaranteed to be a quiz question.
Something wrong with my.
Independent?
What is that?
Totally independent?
Yeah, the validation and the test set have nothing to do with each other. So running a test on the validation set doesn't give you any information about how it's going to perform on that test set, and vice versa. So do you expect the fully grown tree to show better or worse accuracy on the test than the validation? You have no input to that. But do you expect the fully grown tree to show better or worse on the test and validation set than the training set? I would expect, God, I have to be careful. It's like anytime he asks the word expect, you just say no, like no guarantees. But a fully grown tree is supposed to be 100% on the training set. That's kind of by definition what a fully grown tree does. So you would expect it to be worse on any other test set. On any other set of data, you'd expect it to be worse.
But do we still consider test set data for? I thought we do for a classification tree.
You do, but he was asking, well, what do you expect the how do you expect the performance on the test to compare to the validation, given it's a fully grown tree? And his answer was, they have nothing to do with each other. There's no correlation.
Well, how do you test it then?
Well, no. He's saying specifically, do you expect the tree to be better or worse on the test set than the validation set? Which is different than the training set. So why is it perfect on the training set? And then given what you know about the training set, do you expect that the test set is going to be better than the validation, or the validation is going to be better than the test?
Okay, so that's only on a fully grown tree then. What about like a different tree, like a best pruned tree? Would we still use those to compare?
Well, you can make a statement about how you might expect the tree to perform relative to the training set, but you wouldn't necessarily make a statement of how you expect the validation to perform against the test. Is that true? No, I think yeah. I have to think about that, because I think in general he said, test is worse than validation is worse than training. But
there's another one further
down. Of a fully grown tree is perfectly overfit. It's perfectly fit on the training data. You can't make any inference about what it's going to do on any other data set. Because it's fully grown. So what were you saying, Amy?
No, I was saying that there was another one further. I think like maybe 4 slides down, like maybe another page.
Yeah, there was another one.
Why no perfection on the training set? And I think the answer for that one was different. Do you expect?
Yeah, I think that's what Ben was asking also. Why no perfection on the training set? Because it's not a perfect, it's not a perfectly tailored tree. It's not a perfect split. And do you expect the best prune tree to show better or worse accuracy on the test set than the validation set? The best prune tree is selected off of the validation set, right? I think because the best prune tree is selected based off of how it performs against the validation set, I think then you expect the test set to be worse than the validation set.
Okay.
Yeah, Garrett. Best pruned tree rules using validation data. And because these rules are developed against the validation data therefore then provide information into the tree, into the classification. So because it provides information into the classification, you then expect it to show better accuracy on the validation set than on the test set. But in this case, in the fully grown tree, only the training set is used to provide information on the classification tree. Neither the validation nor the test set are used. So no information from validation or test flows into this on the fully grown tree. Therefore, you can't make any statement about the relative performance on the test compared to the validation.
Oh, that's what I did wrong when I ran my validation. We were getting ones and all ones as well. And we thought we did something wrong, but it's because we did a fully grown tree. If you look at the classification summary on the
Yeah, that's
training,
right. Yeah.
Yeah. Okay. That makes sense now.
Yeah. If you run a fully grown tree, yeah. So that was the first thing I did too in mine. I ran a fully grown tree, and I was like, wow.
This is great.
Yeah, I said, okay, this is something people really do. All right.
Yeah.
And then we went through, and he did the thing about the best pruned. And remember, I asked him in class, is there a name of an algorithm instead of best pruned tree? Because I was trying to find an algorithm for best pruned, and there is no name. If you look up best pruned classification tree algorithm, there's nothing by that name out there. And it's because it's called something else in the wild. So I think best pruned is a concept that the ASDM folk came up with.
Okay. I was gonna joke that it's called bonsai.
That would, they should put you in charge of their branding, because that would be much better.
Awesome.
Yeah, that's a solid name.
Yeah.
Solid name.
Yeah.
Best pruned is lame, but bonsai tree is awesome. Have you guys watched Cobra Kai?
Yeah.
Nope.
No? Are any of you fans of, or any of you watch The Karate Kid growing up?
Watched it a long time ago. I don't really recall it.
Yeah, I watched it.
I watched the first
Yeah.
one.
So Netflix did a series called Cobra Kai, which brings back the main characters.
Wow.
And
Okay.
it is infinitely better than it has any right to be. It should be stupid. It should be unwatchable. It should be absolute garbage. And somehow it is not. Another one, if you guys are looking for things to watch, is have any of you seen the Van Claude Van Johnson on Amazon Prime?
Mm,
No.
Do you guys know who Jean-Claude Van Damme is?
yes.
Okay,
Muscles from bristles.
yeah, he did exactly muscles from muscles. He did a series on Amazon Prime called Van Damme Van Johnson, something like that. It has no right to be any good at all, but it is utterly amusing. Fully entertaining. Anyway, bonsai tree. That's
New name.
new name. Better name than best pruned.
Hey, I have to drop now, but thanks for meeting. This is helpful. I'm glad we went through this because now I can apply
Yeah.
it to my
Yeah.
analytics project. So
Yeah. Now watch that. He's only going to ask us homework questions, right?
yeah. Sorry, Ben.
No, there's no way to win.
So
Tree.
real quickly. Fully grown tree, no connection between validation and tet set because it's a fully grown tree. Best
It's
pruned
only
tree,
created by looking at the training set.
right? Best pruned tree. Is there a better or worse accuracy shown going from validation to test?
Yeah, because the best pruned tree is selected using validation data. It's therefore tailored slightly towards validation data, which means it should perform better on the validation data than on the test data.
Perfect. Okay.
Yeah.
That makes sense.
All right. Have a good night, everybody.
All right.
All right, good night,
Good
everyone.
night.
Good night.
Good
Camille.
night.
Oh, sorry. I didn't mean to end it for everybody. I was just gonna.
No, it's
drop.
okay. It's 12. It's 11:15.
Yeah.
Good to
Yeah,
go.
it's a
Yeah,
solid
I
time,
think I-
man.
Okay.
Yeah, it's a good time. Thank
All right,
you.
Good night.
Goodbye.
Thank you.
Good night,
Good
all.
night, everyone.